Hi, my name is James, and I'm going to demonstrate my IFB 102 mini project that I've been working on throughout the past few weeks here at the Queensland University of Technology. My project includes making a security camera that has the ability to detect motion, activating a camera that will then photograph the action, with the data being uploaded to a web storage service known as Dropbox, which is accessible from any location providing you have an internet connection. The project includes a series of hardware components, such as firstly, the Raspberry Pi Camera V2 containing a Sony IMX219 image sensor, capable of producing 8 megapixel images at a sufficient enough quality for this project. To enable the camera, I had to use the raspberry config command in the terminal to enter the interfacing options and enable the P1 being the camera. Secondly, the passive infrared sensor, or a PIR sensor, was connected to the GPIO using a 5-volt pin, a ground pin, and the GPIO pin to transfer data. The PIR sensor detects the change that occurs within the infrared radiation being emitted within its range, as everything has some level of infrared emission. Both these parts are hooked up to the central computer being a Raspberry Pi, a small budget computer with highly power efficient and optimized internal components that are more than capable of handling a script using the external hardware. The Raspberry Pi contains also a Wi-Fi chip and is run off Raspbian, being an open source Debian-based operating system. I've encased my entire camera within a small plastic containment to offer some sort of anonymity. For the script, I decided to use Python, despite being less optimized and slower than many other programming languages. As Python is a dynamically typed interpreted language, the script is quite short, not requiring much computing performance. Therefore, the performance difference would be unnoticeable in comparison to other conventional languages. Within the script, I imported 5 libraries, such as firstly the GPIO library, which enables Python to connect with anything connected to the GPIO of the Pi, which in this case is the PIR sensor, which Python will be required to obtain recordings from. Secondly, the Pi camera module, which gives Python access to controlling the Pi camera in order to produce and store images. The resolution of images can also be altered within the camera resolution bound. 480p was chosen as the ideal resolution to produce small file sizes, allowing for a quick upload with a sufficient clarity. The Dropbox library was imported, allowing Python to connect and upload data to Dropbox using a generated access token. The time library was imported to implement time blocks within the script, and the datetime library was used to add the exact time a photo is captured to the file name. Some of these libraries were not pre-installed and were installed using the advanced packaging tool in the command line. When capturing images, the image file names must be unique, otherwise the images will replace themselves. So a text file with an integer value is opened in the script, and the integer value is increased by 1 and saved to the document every time an image is captured, ultimately allowing the program to be continuously relaunched with ease. So now I'm going to demonstrate my project in action. So I will launch the program through the terminal. As you can see, the time block is allowing time for the sensor to stabilize. Now the program is detecting nothing, and once the sensor detects a change in the infrared readings, the camera activates, takes a photo, and then the data is uploaded to Dropbox. And that is everything. Thanks for watching.